Okay, so there are a couple different types of confirmatory tests that you can use. Gas chromatography is one of them. In chromatography in general, and you'll see this in other sections as well, chromatography has two phases that it uses. It has a stationary phase, which is some sort of solid or thick liquid that will line a tube or a column. And then in this case, the mobile will be an inert gas like nitrogen or helium. And the mobile part is going to move across the stationary part. And when it reaches limits, it will leave marks on the stationary part. So this analysis will show a peak that is proportional to the quantity of the substance present. And it uses retention time instead of retention factor for the qualitative analysis. So when you're looking at the math portion, it's retention time. It's how long it takes it to go through the process, as opposed to how much movement you have of that particular element. So, and it's represented as a graph like the one shown on the screen. There's multiple uses of gas chromatography. Usually you'll see it in combination with mass spec, so GC-MS is usually what you see. It's not considered a confirmation test or a confirmatory test by itself, but used as a separation tool, so then mass spectroscopy or mass spectroposky. Like I said, they're two of the hardest words to say. And infrared spectroscopy can be used to make that final identification. So, it's used to quantitatively measure the concentration of a sample. So it tells you how much quantity is of that drug in it. As far as courtrooms go, there's no real requirement to know the concentration of a substance. It doesn't affect the guilt or innocence. So if it's 100% pure or if it's only 25% pure, it doesn't matter in the courtroom. What matters is, did they have the drug? Did they use it illegally? Did they sell it to somebody that died? That's what they look at. One of the confirmatory tests, so gas chromatography is going to separate the drug, and then you're going to use spectroscopy, which will use electromagnetic radiation to go through the sample that you've separated. The spectrophotometer is the instrument that's used to measure and record the absorption spectrum, which tells us, and each drug will have a specific mass spec. It'll be a chart that you look at, and it'll give you a specific wavelength, and it's like a fingerprint. It's unique to each drug. So the way that spectrophotometry works is that you have a couple different components. You have a radiation source, so some sort of lamp. You have a frequency selector where you can determine how much you want to use. You have something to hold your sample. You have a detector to convert the electromagnetic radiation into a signal. And then you have a recorder that will take that signal and put it onto paper or put it onto a record. So there's three types of spectrophotometry that we use. Ultraviolet, which uses ultraviolet light. Visible, which uses visible light. And then infrared, which uses infrared wavelengths. Infrared spectrometry is where the materials will absorb the energy in the infrared or near infrared region on the spectrum. So it compares the infrared light beam before and after it passes through the sample. The result will be an absorption or transmitted spectrum, which is shown to the right, and it gives a unique view of the substance. This again is like a fingerprint. So the one there is for ethanol, which is alcohol that people drink. So alcohol that's found in beer or wine or liquor. Mass spectrometry. Like I said, gas chromatography is used in combination with mass spectrometry. So the gas chromatography is going to separate it out, and then the mass spec is going to break it down and determine exactly what it is. These are two examples of mass spectras, or mass spectrometries, and their printouts. It kind of looks like a earthquake graph. There's peaks and valleys, but each molecular species will have its own unique mass spectrum. So aspirin is up there at the top, and then acetaminophen, which is Tylenol, is down here at the bottom. And you can see that they have two totally different footprints, even though they have the same, they do the same thing. Infrared spectrophotometry and mass spectrometry both work really well in identifying pure substances. However, if there's a mixture, it's very hard for it to identify both substances or both techniques. So they do have a catalog of knowns that you can go through, and you can look at all of the mass specs to compare the ones that you get to determine what it is. And that's it for our confirmatory tests. Thank you for listening.